Welcome to another episode of Code for Thought. For this episode, I'm very excited to talk to Ben Goldacre. Ben has an outstanding career in medicine, science and science communication, and is the author of many articles and books, like for instance Bad Science, which you probably know. For this interview, I wanted to focus on a UK government report Ben and his team have been working on. The report is called Better, Broader, Safer, Using Health Data for Research and Analysis, and was published in April 2022, that is, this year. Although focusing on healthcare, the report makes a number of recommendations, including that research software engineering should play a more prominent role in science and healthcare. And indeed, Ben has been a strong supporter and promoter of the RSE community, something he reiterates several times in this interview. But the report doesn't only make a very strong case for having professional software engineers in research, it also emphasizes that sharing code and open science are needed to tackle today's challenges. In previous episodes, we talked about free software more from a political and social background. But Ben emphasizes the simple practical needs for open science and software to help us advance science and healthcare in the 21st century. I strongly recommend to take a look at the report, as many of its findings might not only be relevant to the UK, but also to other regions and countries. And here now my interview with Ben Goldacre. Hello, Ben Goldacre. Thank you very much for finding the time to meet with me today. I'm very excited about this interview. I'm sure that a lot of listeners will know you, but maybe you can quickly introduce yourself.
Yeah, sure. Well, and firstly, thanks for having me. So my name's Ben. I'm a doctor. I trained in medicine at Oxford and then London. Then I trained in psychiatry at the Maudsley. And then I trained in epidemiology, which is essentially applied medical statistics at London School of Hygiene and Tropical Medicine. And then in 2015, I came to Oxford to set up something called the Data Lab, now rebranded as the Bennett Institute for Applied Data Science. And I'm Professor of Evidence-Based Medicine here in Oxford. And I run a large team turning health and scientific data sets into tools and services, as well as pure academic journal paper outputs. And along the way, I've also done bits of public engagement output, including writing books and journalism for the general public on problems with stats and evidence and data. I wrote the Bad Science column in The Guardian for a decade, did a book called Bad Science, and a bunch of YouTube videos that have got a few million views and all of that sort of stuff. And then more latterly, I've done bits and pieces for government, which is actually, in some respects, quite similar skills to a lot of the other things, because it's always all about spotting problems, but also communicating and engaging on technical issues.
So people will know you from Bad Science. But what I want to talk about is a report that you published recently, that came out recently. I think it's called Better, Broader, Safer, Using Health Data for Research and Analysis. And we're going to come a little bit later to why I want to talk about this. But first, could you perhaps explain why this report and what does it try to address?
So the report sets out to address a long-standing challenge, which is that the NHS has health data of almost unparalleled potential, really, especially in the GP data set, where we've got incredibly deep, incredibly granular data about almost every health service contact, every prescription, every blood test, every referral, every investigation, every diagnosis ever recorded in primary care. And it's not just detailed and granular, it's also incredibly good coverage. So it covers 58 million patients in England alone. Because of that, for a long time, people have said the NHS has got enormous potential, a global powerhouse, because you can use this data for three things, really. Firstly, you can use it for traditional academic research, which is what people in epidemiology like me have done for many years. Secondly, you can use it for innovation in the life sciences sector. And then thirdly, you can use it to improve the quality, safety and efficiency of health services by looking for problems and outliers. And then also, if you do something to try and address those problems, you can use data to monitor and check and see if the thing you did really did help. But the problem is people have been saying for many years, this data has huge potential and never quite capitalizing. And we've thrown money at it, but we've also ended up with, alongside quite slow delivery, also a lot of privacy problems, including the care.data program, the more recent data extraction and dissemination program, which wisely, in my view, was paused and has now been fixed such that it's actually a very got potential to be a very safe, but also a very productive and efficient platform. I was asked by Secretary of State with a very broad terms of reference with 12 key questions to go out and find out essentially what the barriers were and how we could get better, broader and safer use of health data. So better meaning more good, important questions being answered. Mm-hmm. Broader meaning a wider number of people working on the data, because that's a key way to getting productivity. More heads means more good ideas and more outputs. And then lastly, safer means how can we square the circle? How can we have our cake and eat it? How can we have more people working on the data, but also keep the risk as low as possible? And it was initially framed as a rapid review in March 2021. It only got published last month, 7th of April, I think. Yeah. I'm sort of slightly embarrassed to say it's 117,000 words. We can talk a bit more about why that was necessary.
There's a lot to talk about, isn't there?
Well, also, you cannot shy away from the fact that these are technical problems. And I think part of the problem in the past has been, for good and bad reasons, often the discussions around how to address some of the strategic and practical problems have often relied on aphorisms or people saying, well, I think it's really important that we put patients and the public first. And of course, that's important, but there is also a lot of really important practical work to be done. And also just, without lifting the bonnet too much, separately to that, we handed in sort of 30 pages after a few months and people said, this is great, but we'd like more detail on how you would actually do all of this. We handed in 80 pages and then they said, well, this is great, but can you give us a bit more on the justification? And then by that stage, other life had stepped in, so it took a bit longer. But it's there, it's open, and I would strongly encourage people to read it, actually. Anyone who writes something like this would say, not enough people have read it, you should all go and read it. But actually, I would encourage people to read it because we set out, and when I say we, really I mean me and Jess Morley, who is the lead researcher on the review and who works with me in Oxford, as well as obviously the wider team working on the review. The text is long in part because it also contains a detailed description of so many important background things. Indeed. We literally have tables and pictures showing you what actual raw GP data looks like to help readers understand exactly what the challenges are for data curation to work from those raw administrative records up to an analysis-ready data set. We literally describe the sort of basic principles of best practice around sharing your code and why it matters and what GitHub is and what version control is and what code review is. And we did that in part because I feel very aware that there isn't really a curriculum for people in policy roles or adjacent technical roles, people who know about epidemiology or NHS service analytics, but there isn't really a curriculum or a training program to help them know more about the practical and technical underpinnings in fields adjacent to their own technical specialty. So it's not geeks versus non-geeks. It's helping different flavors of geek understand adjacent geeks, as well as helping non-geeks understand all geeks.
And hence the length of the report, which I actually did read, at least in parts. And that brings me to the reason why we're talking about this report, because it also mentions research software engineering and research software engineers.
Yes.
You kind of alluded to that already, but why did you actually put that into the report, research software engineering specifically, and what do you think it will be able to bring to the table?
I think there's been a catastrophic failure of strategic vision around the use of health data for research in the UK. You analyse data by writing code. That's how you do it. And yet, we haven't really foregrounded the importance of software skills in that domain. In the review, I talk about the importance of, first of all, if you're going to have this whole field of activity where people are writing code to analyze data, you really need to have, at least as part of your wider team, people who write code for a living, people with many years of deep experience in software development and in writing open and reproducible and adequately documented code. That in itself is a bit of a new idea, but there are also some really important challenges around how you get that done. And one of the problems I think in the past is that because it hasn't been adequately recognized that software development is such a core part of the research enterprise, that software development really is eating research when it comes to research using data. a moment ago I was talking about different flavors of geek with different partially overlapping realms of expertise. I think one of the problems is that newer forms of technical skills are often harder for the system to embrace, resource, task, and also recognize and reward. And one of the challenges that I see in my own space, which is epidemiology or applied medical statistics, is that the more long-standing skill sets, like being a statistician, that's sort of been around for 100 and a bit years as a sort of prominent profession, or being an epidemiologist, somebody who thinks about the conceptual structure of the analysis. What are the confounders? What are the biases? What's the overarching clinical research objective? Those types of skills are highly valued. But when it comes to the people actually writing the code to do the data curation in particular, and the data analysis, those are often regarded as rather low status activities, and they're quite invisible in many cases. So a lot of what we talk about in the review is the importance of naming those tasks, giving them independent status, and that in practical terms means UKRI and NIHR giving them standalone funding for fellowships for people who are research software engineers, because it's only when you're in control of your own money that you're in control of your own destiny in academia. And being in control of your own destiny in turn means that you can set the priorities for projects. And so one of the great recurring shortcomings that was clear from all of the many, many interviews that we did for the review, including over 300 individual interviews and then many, many more people in wider stakeholder groups, it was clear that developers were often considered to be a sort of client service. You go and tell a developer what you want them to do, and then they go and do it for you.
Indeed. Yeah.
Whereas, to my mind, what's much more successful, and what I have found to be much more successful in my own work running the Data Lab and now the Bennett Institute in Oxford, is to have software developers as a core part of the creative, intellectual, academic team, understanding what the overall objectives are and leading elements of the projects, and in particular, unambiguously leading on the big challenges around data curation, secure analytics, and so on. Now, that in turn then raises interesting challenges around where do these people come from?
I think in your report, you actually also highlighted RSEs being a collaborative and as well as a creative science. But collaboration actually comes with challenges in its own right, because it means that there's a software developer, say there's a pool of software developers, they have their own budget pot, and then there is a scientist, an epidemiologist, a statistician, they have their own budget pots. And before them all to work together, these budget pots need to talk to each other. And I think isn't that one of the challenges that we face today, that it's pretty much siloed. Right, you work as a statistician or you work as a software engineer, but you can't sort of have in this middle space. So how do we create that kind of team science or collaborative science?
So I think that's one interesting practical challenge. I think in part it possibly flows from a problem upstream, which is that we have probably underpriced the challenges of working with large, for example, NHS electronic health record data sets. There's an aphorism that has been kicking around for a couple of decades that that data is the oil of the 21st century, as if it's just sort of sitting around waiting to be picked up. And I think, in particular, when you're reusing administrative data that you didn't have to pay to collect in the first place, there's a bit of a tendency to view it as somehow free. It's just on the table and you just pick it up and just use it. I think in reality, that tends to fall down quite quickly. So the ABPI, the pharma lobby group, have written in the past and told us during the review that they estimate around 80% of any project that their members engage in with NHS data sets, about 80% of the work is just data curation. The validity checks, plausibility checks, but then also taking the very raw records, which are one row per clinical event or one row per prescription, one row per blood test, one row per investigation. And you have to process all of that very, very challenging data, which isn't messy, as some people say, but rather it wasn't made for us to do research on. It doesn't contain a variable that says this patient does or does not have diabetes. If you want that variable, you have to query God's giant SQL database in the sky. You have to make that variable, and you make it by looking at all the previous diagnostic codes, which may be incomplete or may be wrong. You look at the blood tests for signs that they've got diabetes. You look at the treatment history, and you have to think then about, what do we mean by diabetes? Do I include an early diagnosis of pre-diabetes that may not be called pre-diabetes, but somebody's diagnosed with diabetes, and then they only get one unusual blood test result with a bit of sugar in it, and then after that, nothing ever again, and they never get treated? Do I include them as having diabetes? And then the answer is, well, you might do if you had a very inclusive definition for one analysis, but maybe not for a different analysis where you wanted to be very specific about your criteria for diabetes. So all of these enormous challenges around data curation that require domain knowledge, first of all, but that also require quite deep technical understanding of what the underpinning data is and its shapes and so on. But also, when you're dealing with the electronic health records of an entire nation, as we do, for example, in my team's project, Open Safely, that's about 70 billion rows of data. Mm-hmm. So it's not actual big data in the sense of, sort of vast petabytes. It's slightly irritatingly big data. So you've got to be thoughtful about how you shape your queries. And also then there are all kinds of interesting computational challenges around what is the correct level of abstraction. Mm-hmm. At what point am I going to start saying, we're going to turn this into a function in a library, and this is going to be the standard way that we encourage everybody to do it, because then it'll fit into a framework that will then lend itself in turn to efficient point-and-click analytics, or being part of a long arcing chain of analytic processes and data curation processes that can also preserve privacy or lend themselves to automated output checking or anything else. When you start getting into all of that, then by God, you're really going to need some very, very good software developers. You're going to need very good software developers who can make autonomous decisions for themselves. You're going to tell them the overarching objectives, and they're going to understand those overarching objectives because they're going to be embedded as part of a team to start understanding what epidemiologists do for a living, what their objectives are. Similarly, NHS analysts understand the structures of the NHS data, but also the administrative structures of the NHS to understand what kinds of data feedback clinicians and GPs and practice managers in the NHS want, and so on. And if you get people who understand all of that, then you have developers acting as part of the creative, intellectual, academic research and analytics team, turning raw data efficiently and reproducibly and reliably into finished analytic outputs. You asked at the beginning about money, about how do you pay for that stuff.
Yes, indeed.
What I've tried to set out there with a long and arcing description of a real problem where developers contribute alongside traditional academic researchers and clinicians to fixing some data curation and analysis problems. What I've tried to set out there is, first of all, the extent to which all of that work needs to be entwined. Secondly, the extent to which all of that work is actually rather more laborious than has previously been understood. Because a lot of the time, all of that data curation work is basically invisible, and it's sort of done actually in many cases quite badly. So typically that data curation work is done duplicatively, differently in each time. Barbara will do a SQL query for you if you tell her what you want, and she'll put it in the shared drive. And then Tom had a PhD student who did something in something called Python, but if you just click on it when it's in the same folder, it should dedupe all of those things and reshape it wide, and then you can use it in R. Those are typical analytic pipelines for electronic health records.
Exactly, often done by people who just started doing software development rather than being trained in it.
Correct, yes. Yeah, the PhD student who's better at R than most other PhD students, but not a professional software developer. Now, the problem with that is that means everybody's doing their data curation work in slightly duplicative ways, often in ways where you can't see it because there's no place where it's actually written down with version control and accompanying technical documentation, and nobody can be bothered to write down, copy and paste your .sql file and then write a bit of text around it saying, well, what you've got to do is get Barbara to do that, make sure that she's using those tables, and then put that in that. Nobody wants to write down that to create a reproducible analytical pipeline, and nobody ever does. All of that busy work, that duplicative manual labor that's done around curation under the traditional model, is time-consuming, underpriced, not done as well as it could be. And so when you come along and say, well, actually, maybe we should start writing some good standard functions for data curation, then you run up against the problem which you raised, which is people saying, sorry, what, you want to pay somebody 60 grand a year to what? To write some commands in a text box? Mm-hmm. You go, yes, absolutely. Secondly, and crucially, it shows the enormous productivity gains that you can get when instead of duplicatively doing things in a very manual way to lower standards, instead you start building on the power of computers to do things that computers do well. Now, all of that kind of creative work, driven by a deep understanding of the analyses and the work that's being done, alongside deep, long-held and hard-earned software developer skills, those come about from teams and individuals who have some autonomy. They don't happen if you say, I'm going to pay one bureau £20,000 to do one curation task. They come about if you have people working in enduring ways in teams, but also if you take software developers with generic software developer and data science skills, and you spend many months teaching them about the domain in which you're hoping they'll work. So in my case, in the case of this review, it's electronic health records, their structure and what you plan to do with them. And then when you've done that, you do also need those people to have autonomy because they understand how to organize their work and their projects best. And so that's why you need UKRI and NIHR to have standalone fellowships for software developers working in given spaces so that they can lead projects. It's also why you need NIHR and UKRI to have standalone funding for software projects that are used. And I think one of the great mind shifts that is long overdue, and which actually has begun to happen in parts of UKRI, infrastructure, data infrastructure, is no longer beige boxes in big glass and metal buildings. Data infrastructure is people and code. And ideally, and I'm sure we'll talk a lot about this in a moment, that code needs to be open code.
Indeed. And I think that's something that we should talk about a little bit more, the importance of open code and open source code to science. Because very often, and I think you kind of touched on that a little bit, that Barbara is writing some code, a SQL query that ends up somewhere on her drive. Then she's got a PhD, moved on to something else, and then somebody needs to write it again because that code can't be found.
Yes.
There is that immediate need, but there's also the other aspect of knowledge sharing that goes a little bit wider. In what sense do you think that open data and open software can contribute to your goal of having better, broader, and safer?
First of all, sharing code within teams that are working on similar questions is obviously critical. People talk about the value of collaboration, and of course, science is all about collaboration, but it's not just collaboration in terms of going to meetings with each other and having conversations. It's also deep, rich technical collaboration on deep, complex technical issues. And the way that you collaborate on those complex technical issues when you're working with data, when you're curating and analyzing data, is by writing code. And you develop code interactively and collaboratively. And traditionally, for people outside of academia, you do that in systems that allow whole teams to track and annotate the changes and attribute those changes and to put adequate technical documentation alongside those. I don't believe in open code as the right answer for scientific research and for coalface analytics in the NHS. I don't support open code for any political reason. It is just simply a practical necessity. If we all worked for Cadbury's or National Rail or Barclays or something, then sure, we could all be part of one GitHub repository which is completely closed and everybody in our organization is allowed to see it, but nobody else is allowed to see it. You might just about get by with that. But in the NHS or in academia, there are these huge, vast, arcing, sprawling chains of reciprocal interdependence across multiple different groups, multiple different teams, in multiple different organizations. And actually, administratively, I cannot even begin to conceive of the cost and complexity of an access control system and the bureaucracy around it that would allow only some people to see the code that was written to curate and analyse NHS data, but not others. I mean, in the NHS alone, there's 160 hospital trusts with multiple commonalities in the work that they do, 200 CCGs, 43 integrated care systems, a dozen regions. There are 6,000 practices. There are endless primary care networks. There are commissioning support units. And then, even after you've enumerated a subset of the actual formal NHS organisations, on top of that, there are adjacent organisations like bits of academia and also parts of the private sector where people go and say, hi, can you help us out? Can you come up with some good code lists and logic to identify patients at higher risk of having a problem with their blood pressure? And they say, yeah, sure, fine, thanks. So how on earth could you possibly draw a perimeter around those people, but not other people? And also, what benefit would it bring to even try and draw that perimeter? So I believe in open code because of the obvious practical benefits. And I think you could not possibly get the benefits of people collaborating on code in a closed way in any practical sense, either for NHS service analytics or in universities, by trying to have some kind of access controls for that code, because the number of people who need access to it are just simply too large and too dispersed. And it's really worth articulating, I think, the harm that is done when that code is not shared. So we were given multiple examples during the review of extraordinary situations.
Name one. Could you name an example?
I will be very gentle and generous, Peter, and not pick anyone out arbitrarily in a chat. For example, people saying, well, we had another part of the NHS come to us and they said, we've paid somebody to create an algorithm. It's always a bit worrying when people say algorithm, because that often suggests they're sort of overstating the complexity. We paid somebody to make an algorithm to identify patients at high risk of needing a particular intervention. Can you check that you agree with it and that you think it's working correctly? And they said, yeah, sure. Just send us over the SNOMED codes and the ICD-10 codes that they were using and the logic that they were applying on top of it. Typically it would be patients who have had these clinical events recorded, but not these clinical events recorded within this date range if they also have these demographic features. And they were told, no, we can't let you see it. It's a proprietary algorithm. And they'd say, well, okay, well, then you can't do anything with it. And how do you hope to use it elsewhere? Now, just to be clear, there's nothing wrong with paying people for their work. But if you paid somebody to produce something like that, it just makes much more sense to do it on a buyout basis, where it can be reviewed, evaluated, iteratively improved, and reused. Similarly, you'll often find public funded projects that aim to create a new way of spotting whether there's, a GP practice is a particular outlier for not hitting some of their safe clinical practice objectives or safe prescribing or some of their quality objectives. And again, there are some quite celebrated, publicly resourced projects in that space where they've spent a lot of time gathering a lot of clinical knowledge and then encoding it in SNOMED codes and attendant logic. And then you say, oh, that's great. Can I see what you've done? Just so I can check. And also, could we think about, using similar approaches elsewhere? And people say, oh, no, sorry, that's closed. And it being closed raises two obvious problems. First is, I don't know if it's any good. And also it blocks any kind of collaborative enterprise around people engaging in reciprocal checking and improvement and iterative modification over time. But also it absolutely blocks people reusing things, but also finally for rather puzzling and often unrealistic commercial needs. So, the final bit is I think often heads of department or people in NIHR who are writing boilerplate contracts, they don't really understand what scientific software or research software or these kinds of code lists and logic actually are. They know that software is a thing that you pay money for in office worlds to get a copy of Microsoft Word on a DVD. So they think, oh, people in this organization are making software, so we must protect their intellectual property. And so then, we heard from people who said, well, I wrote an enormous amount of quite laborious R code, but I was told that we should try to monetize it. And I said, well, do you really think, would you pay for it? Do you think anyone's ever going to pay for it? And they said, oh, God, no, of course not.
There's quite a bit of a mismatch, or shall we say, overstated expectations of what a software can deliver, what it should deliver, and what it actually does deliver. So how do we get away from this then? You already alluded to that in your team, or that's at least my understanding, that you have experienced software developers, but then you train them on a domain level basis in epidemiology or in that field that they're expected to work at. So what else can we do to put a software a little bit more in a prominent space than it is currently in?
The 5 key things that we said on getting better use of software. First of all, the conversation that you and I have just had has been rather discursive because of a lot of common knowledge between us. I think for the outside world, it's actually quite difficult in less than 30 seconds, in less than an hour, to encapsulate what it is that we're asking for. Now, very, very luckily, Government Digital Service and Office of National Statistics over the last few years have developed a brand called Reproducible Analytical Pipelines. And that's a set of best practices and training that's available through ONS. It specifies in really good, easily understood terms with a kite mark, with a kind of badge of authority from the Office of National Statistics, the minimum standard for academic and NHS data analysis. It talks about the importance of version control, of adequate documentation, of code that's re-executable and avoiding point and click. But if you have to do point and click, then you have to document it. And they talk as well about how this isn't just about making things more efficient, but it also drives up quality. It avoids unnoted errors. It makes assurance easier. Now, this approach has also got very strong support from the Office of Stats Regulation, which is a very authoritative and influential body. Our first recommendation is to avoid inefficient duplication of work, to avoid unverifiable black box analyses, to make each new analysis faster. UKRI and NHR, the academic research community, and the NHS analyst community should promote and resource training and use of reproducible analytical pathways. And that's crucial because it's an existing brand. It's not you and me going, well, look, there's this thing called version control. You probably haven't heard of it, but how can I explain version control? So instead, you just go reproducible analytical pathways. There's training, there's best practice, there's documentation. Do that. So that's recommendation number 1. Recommendation number 2 is to ensure that all code for data curation and analysis that's paid for by the state through academic funders and NHS procurement, ensure that all that code is shared openly with appropriate technical documentation to all data users. And that's really important because, as we said, data preparation, analysis and visualization, that's complex, fiddly technical work. It requires collaboration across many individuals in different organizations they might never even meet. And the only way to manage that shared complexity on this technical challenge is by sharing information, as in other technical fields. The third recommendation is to recognize software development as a central feature of all good work with data. We say that UKRI and NHR should provide open, competitive, high-status standalone funding for software projects and developers working on health data. But then secondly, and we haven't really touched on this yet, universities should embrace research software engineering as an intellectually and academically creative, collaborative discipline with realistic salaries and recognition. Because that's been a real problem historically, is that software developers in RSE teams may have had a slightly better deal over the last 10 years since the Sustainable Software Institute and the RSE community got going. But I would suspect, certainly in my field of people doing research with health data, for the most part, software developers are rather isolated in a patchwork, often quite standalone, often considered to be not a spare part, but a sort of odd peg. Where do we put you? Do we return you in the ref? What are you? What pay scale should you be on the same pay scale as the person who fixes the printers in IT? Are you really a high value employee if you don't manage lots of other people? And I think that's a real problem, and it speaks to the novelty of software developers, because I think the state and the NHS and universities, they can cope with high cost professionals in the more traditional and more well-certificated professions. So universities routinely pay doctors, clinical academics, they pay them their NHS salary. Universities pay accountants who are highly trained, they pay them according to a standard salary. Or lawyers, people in the contracts team, they pay them a salary that is concordant with.
They don't know quite how to play software developers. They do that in some instances. So at UCL and other universities, there is a recognition, and there's now an emerging career path. But I think you're right. It's not quite consistent. Within the UK, you still hear stories where research software engineers are indeed buried somewhere in a department and barely recognized. But then there's also the lack of recognition in the publication, because publication is still what's driving science in a lot of cases.
Well, I agree. Although I was in a slightly awkward meeting recently with a very senior epidemiologist who said, gosh, Ben, I don't know how you've managed to retain and recruit these software developers. I find it very hard to recruit people because, of course, they're not well paid, but also they don't appear on any papers or any grants. And I said, well, I put all of mine on all our papers and on all our grants, and they pay as they possibly can. It's not hard to, research software engineers. Of course, they should be on papers. They are part of the core creative, intellectual, and academic research team. And actually, it's very interesting to look at different cultural norms in different sectors. My first research work, when I dropped briefly out of medicine between preclinical and clinical medicine, I thought I was going to go and do functional brain imaging for a living. I was really in love with cognitive neuroscience, and the papers that are published in that field, they have the engineers who understand how to drive the MRI machine or the PET scanner, and who write the code to process the images from acquisition up to the point where you can do statistic parametric mapping. I mean, it's very interesting how these norms are so different in different places. In physics, for example, it's absolutely commonplace to have papers that have hundreds of authors. One of the great challenges with health data is that we suffer in the broader health community, both health research and the NHS, we suffer from being early adopters of data and of computing. Because if you look at hospital returns specified by William Farr hundreds of years ago, they're actually rather similar to hospital episode statistics that are still being used today. 96% of all GP practices in the UK, the family doctor practices for international listeners, 96% of those were fully computerized by 1996. If my voice went funny, it's because I was looking behind me to see if I could find, oh yeah, here you go, my copy of Glyn Haynes et al.'s History of UK Computing. Anyway, 96% of GP practice is fully computerized by 1996. If you also look at some of the major statistical techniques, randomized trials or lots of outlier detection, a lot of that was developed in medicine. But the problem is, when you're an early mover, you end up with a lot of legacy projects, a lot of legacy working methods and legacy thinking. It does mean that you have outdated power structures, for example, and we see a lot of those around health data research in the UK in particular. But it also means that you see a lot of outdated assumptions, among which are that somehow the clinical academic, the clinical epidemiologist, and I am one, has somehow unique status in the process of creating an academic research paper using health data. When in reality, if you're doing it well, if you're doing it efficiently, and if you're doing it with a high degree of accuracy, reproducibility, and so on, it will be a team enterprise in which the clinical epidemiologist is but a cog, and certainly should not be regarded as having the sort of absolute final determinant last word on the shape and structure of all of the work, the team. So I think to an extent there's some humility there, and some reshaping of some of the beliefs and expectations around recognition and reward.
We're coming now to the end of the recording. I know it's time's gone quickly, and it's certainly been a very fascinating discussion. But quickly, what's going to be the next step with that report? Because it's coming up indeed with a wide-ranging number of recommendations.
So writing a review like that for government it's an interesting and mixed feast. Of course, I wouldn't want to live in a world in which somebody comes along, writes something like that, and then everybody just jumps and does it. That's not how communities or societies work or should work. The formal story is that the official NHS and government response comes in the data strategy for the NHS, which is coming shortly. Our core recommendation, which we haven't really talked about today, instead of disseminating large disclosive data sets out to multiple locations, instead we should move to keeping that data in trusted research environments, ideally with privacy enhancing tools and complete transparency about every action. That core recommendation has already been very energetically taken up, I'm pleased to say. It's policy. There's a ministerial commitment around the GP data extract that data set will only be available in a TRE. That has moved the discourse on around secure analytics from a situation where millions of people opted out of their data being used towards a situation where everybody, including me, can actively support the extraction of that data because it's going to be held securely. So that's already policy, and that's already happening, and indeed already has funding assigned to it. And then lastly, there is the kind of everyday messy reality of how influence spreads throughout complex social systems. So in many respects, it falls to people like you and me, if it hadn't been me who wrote the report, where you see things that you like, that you support. It falls to all of us to amplify them, to cite it when you're pestering a funder, when you're talking to your boss or your vice chancellor about a given issue. You know, documents like this are here for that purpose, and I would strongly encourage people to use it for that purpose, to amplify the message, to use it as armament, to reference it as a shortcut for certain arguments that need to be made, and to draw upon it in committees or day-to-day work, or write commentaries to amplify it, or wherever it's useful to you. And I would say lastly, of course, I take responsibility for the text, and it reflects the shape that I've put on what we heard, the nature of the challenges. In addition to that, firstly, I'm right about everything that we say here. And where there are edge cases, where there is room, we are actually very clear in the text. There are many things where I actually don't have strong views, and I'm not sure there is a clear answer. For example, some of the challenges around commercial use. This didn't come out of nowhere. I didn't sit in the spare bedroom and write this off the
I wouldn't think
top
so.
of my head. You know, we spoke to 300 people in proper one-on-one or one-on-two meetings, and then had multiple stakeholder meetings, and then had over 100 submissions, and did extensive desk research. Not to be mushy, people often talk about these kinds of reviews or projects or roles as being a great honour, and obviously that makes us all feel nauseous to hear anybody say that sort of thing. But actually, it was a real treat in one go to be able to set aside a lot of time and to talk to that many people. And there was very strong unanimity on a very large number of issues, including some of the stuff that we've spoken about today, other than sometimes by the incumbents who would prefer persistence of prior working methods that help them. It was a genuine, fascinating honour to be able to have those conversations. It won't last, but I don't think there's anybody else who has got quite such a 360-degree view of all of the different segments of the system, not just their preoccupations and their desires and their grumbles, but also their dispositions. Because when you talk to people and when you meet them up close, you can see how they're thinking, how they're feeling. And so it was a great honour and a great fascination, and I hope people will read it. You were kind enough to mention my books. Honestly, I feel sad that I've written something which I think is very accessible, actually, and quite interesting and quite explicit. I almost wish that I'd branded it as a book. And maybe I should, maybe I will, maybe I'll reshape it a bit. And
maybe having it as a government report has maybe a little bit more impact also at the position or at the level where it needs to change as well.
I guess so. There's no one place where everything is decided. The old story about conspiracy theories, which is that they're all wrong because they're all too simplistic, is absolutely true. Government and the NHS and funders and all of the systems and structures that we work with are complex, lumbering, people-driven organisms. And also, as with side effects of treatments, as with personality traits, the same things, for good reason, can do some good and some harm, you know. And actually, a lot of the inertia in any given social system, although it might be infuriating when you can see outstanding problems that really are overdue to be fixed, at the same time, it is actually rather good that large systems and structures of civic infrastructure don't just turn on a dime and go, okay, then chop chop, we're going to completely reimagine ourselves. Universities are a part of that. They've been around for a long time for good reason. They've got survival skills.
They certainly do. And we've got our work cut out, it seems. Thank you very much for talking to me today. We could probably continue for quite some time because there are a number of things we haven't touched on, but I'm afraid we've run out of it. So thank you again and all the best for the future.
Thanks. Hope to see you again. And I will subscribe. Cheerio.